Good morning, students. I believe you all had a wonderful weekend. My name is Ilesomi Tope Joseph. I will be taking you through mathematics, GSS2, and the topic before us is a new topic, which is linear inequalities. Linear inequalities in one variable. Okay. Now, before we move to what we have for today, I appreciate everyone that has been responding to this class by sending their assignment via the mail on the first screen. Keep it up, and I believe you are set for this morning class. Please be ready. Let your jotter be with you, your textbook and your writing materials be with you. So let's commence the class. I will start the class by talking about the correction of the last class. I gave some exercises and I will be doing the correction to those exercises. Okay, the first question is a rectangle has a perimeter of 66 meters. This question is under word problems relating to simple algebraic equations. I think in the past 2 weeks now, we've been discussing about simple equations. We discussed about fractional simple equations, how to solve them, and we now move on to word problems. I think that was where we stopped in the last class, and I gave some exercises, and this will be the solution to all those exercises. So a rectangle has a perimeter of 66 meters. If one of the sides of the rectangle is 22 meters, find the other side. Now, the first thing we are going to do is write out the formula to find the perimeter of a rectangle. A rectangle has two sides parallel to each other. So the perimeter to find, I will make my perimeter to be P. To find the perimeter of a rectangle is P equals 2 into L plus B. Now, what is your perimeter? Your perimeter is 66 meters. Equals 2 into, now if one of the sides of the rectangle is 22 meters, find the other side. So we don't know, maybe it's the length or the breadth, but let's just assume that the length is what we are looking for, then the breadth is 22. Now, it's either you open the bracket with 2 or you firstly divide both sides by 2, either way round. So I'm dividing both sides by 2. Then I'm going to have 33 equals L plus 22. Now, if I'm looking for L, that means I'm subtracting 22 from both sides. That was what I taught you in finding the unknown in a simple equation. So that means your L will be 11 meters. And with this assumption, they do not state that maybe it's length or breadth. So, but we know that in the condition of a rectangle, the length is the longest side. The length is the longest side. So definitely the length will be 22. Yes, and the breadth will be 11. So that's that on that. Okay. There's only for me to do any this thing. You understand the way they're just letters. L can represent anything. L can stand as my home breadth. So they're just letters. But it's just for you to now use your intuitive. Better, I can say 2 into x plus y. So far I defined what x is and what y is. So that is just it. Now the next one is the area of a square is 49 meters square. Find the length of one side of the square. Now let's start with the area of a square. Area of a square is length times length, which is L square. You have 49 equals L times L. Now what is your L? What is that number that when you multiply together will give you 49? That is 7 meters. Okay. The next question, a rectangle is 6 times as long as its width. If the perimeter is 140, find the length and width. A rectangle is 6 times as long as its width. Okay, let's say let the length be L and the breadth be B, because the breadth is also the same thing as the width, which is B. So the length of the rectangle is 6 times its width. That will be 6 multiplied by the breadth. That is the meaning. Then if the perimeter is 140, so 140 centimeters equals 2 into, now instead of writing L now, you just put 6B plus B. Are you getting me? Now divide both sides by 2. That means 6B plus B, that will be what? 7B equals, this divided by 2, that is 70, which gives us B to be what? 10 centimeters. So that means when B is 10 centimeters, when B is 10 centimeters, what is L? Just put it, since L equals 6B, that will be 6 multiplied by 10 centimeters. That will be 60 centimeters. And I told you that in our last class, we can check the statement of the statements of the problem after solving. When we identify the unknown and we solve for the unknown, we can put it back into the statement of the problem. Is it true? Now, since you have your length to be 60 and your breadth to be 10, find the perimeter of this rectangle. It's definitely going to give you 140. So you can validate maybe you are right or wrong. Now, what do we have for today? I told you earlier on that we'll be looking at linear inequalities in one variable. So our limit, what we'll be talking about, our scope is just to one variable. It's just to one variable. What do I mean by one variable? One variable just means one unknown, like x, y, just as we've been doing for a simple equation. Okay? Now, what do we need to achieve? At the end of this lesson, we must be able to identify and use linear inequality symbols in comparing sizes of objects. Must be able to write down the symbolic forms of inequality statements. Must be able to write down the statement that indicate inequalities with symbolic forms. From the word inequality, inequality means not equal. Inequality means not equal. You know, we talked about simple equation in the last class. Simple equation means equal to, when something equals, when an algebraic expression equals to a particular constant, maybe 0, 2, or anything. So that is what we call equation. But this one is inequality. That is, it is not equal. Now, let's start with the topic in view, linear inequality in one variable. In solving mathematical problems, we are all familiar with the equality sign. And this is the equality sign, as you can see here. For example, if you add 2 plus 3, the answer is equal to what? 5. Yes. And however, there are other signs or symbols that can give close meaning to that equality. These signs or symbols include greater than and less than. Now, this is where our work lies. From the word inequality, that is, it is not equal. That is the meaning. Now, this is a sign for, this sign is for what? This sign is for less than, and this is for greater than. Less than and greater than. Less than is facing the left. Greater than is facing the what? The right. This is less than and this is greater than. Okay? Now, we want to look at a particular statement. Okay, we'll be looking at greater than and less than symbols. So, to illustrate the above symbols, consider the figures below. Now, the figure that I will draw is about the bucket of Ade and Suzanne. Suzanne's bucket and Ade's bucket. Okay, do I still know how to draw now? Just pardon the way I draw it. This is for Ade. Just write in your notes, Ade. This is the bucket for Ade. Then this is for Susan. This is for Susan. Now, if you look at what we have, the diagram that we have, don't mind my diagram. This is a bucket, and the one is for Ade, then Susan. Now, there will be some things that we are going to relate with under this diagram. Said Ade and Susan went to fetch water and started to discuss about their buckets. Now, look at the picture of this bucket very well. Look at it very well. You will see that one is bigger than the other. You understand? Now, let's look at the statement that was made by both of them. The first, Ade said, the height of my bucket is greater than that of yours. We use these inequality symbols over and over again. In comparing. If you look at our lesson objectives, in comparing sizes of objects, you compare your food, the food given to you and the one given to your sister. Say, my own food is bigger than yours, this and that. So look at the picture very well. At this bucket, the height of my bucket is greater than that of yours. That is an inequality statement. Susan said, yes, I know that the height of my bucket is less than yours. Less than yours, greater than yours. Then the volume of my bucket is greater than that of yours. And it's true, because a bucket that is having a wide space will take large amount of water than the one that is having a lesser space. Now, yes, I know that the volume of my bucket is less than yours. So we use this over and over again in everyday life. Mathematics happens in everyday life. Okay? Now, let's look at some things. In symbolic form, the above statements, okay, if I mean the above statement, that is this statement here, okay, can be represented as shown below. Number one, the height of Ade's bucket is greater than the height of Susan's bucket. Is that true? This is the height of Ade's bucket, and this is the height of Susan's bucket. Yes, that is very, very true. Number two, the height of Susan's bucket is less than the height of Ade's bucket. Less than, yeah, it's true. It's very, very true. Now, the next part is in numerical form. 3 plus 8 is greater than 9. Is it true? What is 3 plus 8? 11. Is 11 greater than 9? No. Oh, sorry, 11 is greater than 9. Yes, it's true. So that means 9 is less than 11. Also, similarly, you can say 3 plus 6 is less than 8. Yes, what is 3 plus 6? 8. 6 rather. 6 is less than 8. Yes. So we use inequality, which is the greater than and the less than. So let's look at 3 plus 3 is not equal to 9. Yes. So the use of equality sign means what is on the right hand side is the same as what is on the left hand side. When you are using equality, equality means sameness, equal in quantity, in weight, and in everything. But inequality is there are differences. One is bigger than the other, one is shorter than the other, things like that. Okay? Now let's look at another concept, which is greater than or equal to. That is, it's possible that you have something that is greater than and can still be equal to. And you can have something that is less than and can still be what? Equal to. Now, two identical objects or quantities can be compared using the symbols greater than or equal to and less than or equal to. For example, two soldiers with identical heights can be compared during the parade exercise as, say, Major A is greater or equal to Major B. Now, when do we use this concept of greater or equal to? It is when we are not certain, when we are not sure, when the height or what we are comparing are so similar in height, in quantity, and we cannot differentiate. but we can tell, okay, this one is less than, just a slight difference. You know, when we are not sure, we can say, okay, it is less than or equal to. Now, this statement can be made in another symbolic form, like say, okay, what this one is saying is that we can go, you know, from major A is greater than or equal to major B. That implies that major B is less than or equal to major A. Yeah, that is the meaning. Then it should be noted that we are saying the same thing in both cases. So if I'm saying 1 is greater or equal to 0, I'm just using this for an instance. Okay, 1 is greater or equal to 0. Okay, let me use 0. Let me just say an unknown. Let's say x. Okay, 1 is greater or equal to x. This simply means that x is less than or equal to what? 1. That is the meaning. It's the same thing. Now let's consider some. So consider the following numbers: 0, 1, 2, 3. No number is greater than 3 here, or no number is less than 0. Is it true? Yes. 0 equals 0. We can use equal to here. Then we can use the statement of, if we are looking at 3, there is no number that is greater than 3. 1 is less than 3. 2 is less than 3. Then 3 is equal to 3. This idea or statement can be represented as follows. Now look up. Don't be distracted. Look at what we have here. Let n be the number. That is, we want to compare two numbers now. Based on what we have here, based on the numbers we have here, is 0, 1, 2, 3. Now, then for n to be equal to or less than 3, we have n to be less or equal to 3. And for n to be equal to or greater than 0, we have n to be greater than or equals 0. What is the meaning of this statement? Now, n is less than or equal to 3. If you are to list the values of n, that is, you will pick those numbers that are less than 3. And they are, let's say, positive, 0, 1, 2. But it does not say only less, but it's also equal. So 3 is part of this. We are considering this. Don't forget. Now, we are considering again, n is greater than or equals 0. What is the meaning of that? That is, it's possible it is, okay, it's equal to 0, 1, greater than 0. 1 is greater than 0, 2 is greater than 0, 3 is greater than 0. Don't forget, in respect to what we are looking at is 0, 1, 2, 3. Okay? Now, let's start with the first example. Write down in symbolic form. The distance between Funcho's house and the car parked is over 5 kilometers. Is over 5 kilometers. Above 5 kilometers. That is the meaning of that. So that means it's greater than 5 kilometers. So let D be the distance between Funcho's house and the car parked. Between Funcho's house and the car parked. Let D be the distance. That was what we did here. So we want to write it in symbolic form, which is the distance between Funcho's house and the car is over 5 kilometers. So if D is the distance between Funcho's and the car, so that means D is greater than 5, because the distance between is over 5 kilometers. So it's more than 5 kilometers. That is the meaning. So this is an inequality statement. Now the next example says Exe asks Y naira and spends, oh, sorry, this should be dollar, not naira. This should be dollar. And spends $3 out of it. The amount he has left is less than $8. Write this down in an inequality form. Okay, now Exe asks Y dollar and he spends $3. So that means Y dollar minus $3. That is the amount that I spent now. Now, the amount left, Y minus 3 is the amount left, is less than, what is the symbol for less than? This is the symbol for less than. Is less than $8. So that is just the inequality. Okay, think of it this way. You have 100 naira with you. Your mom gave you 100 naira when you were leaving for school, and you spent 20 naira from your way to school. So you will have 80 naira left, and that 80 naira is less than 100 naira. That is just the meaning of this statement. Okay? Now, another example says, in the market, the cost of 1 kg of meat is not more than $15. Represent this information in a symbolic form. Now, let the cost of 1 kg of meat be what? Be C. Let the cost of 1 kg of meat be C. Is not more than, that is, it cannot exceed $15. So that means it will be less, either it will be less or it will be equal to $15. Do you understand it? So it cannot go beyond $15. Now, rewrite the statement using the inequality symbols. 8.5 is greater than 7.5. This one is very simple now. Let's start with the first one. 8.5 is greater than 7.9. This is the symbol for greater than. Then the next one, x plus 5 is greater than or equal to 20. You just write x plus 5 is greater than or equal to 20. So the one to the right is greater than. The one to the left is what? Less than. Now, example 5. We have to rewrite the same thing, okay? Okay, pick your pen and paper and do this for me. Y minus 4 is less than or equal to 12. And y is less than or equal to minus 5. So just do that in less than few seconds. Follow what I did here and do yours also as well. Okay? It's very, very simple. Just try. I know you can do it. Okay, for those that are having some challenges, maybe difficulty in attempting that, it's very, very simple. We have that y minus 4, this is y, is less than or equal to 12. This is 12. Then the next one is y is less than or equal to minus 5. That's all. Simple. Now, in conclusion, in the course of this study, I think we've been able to deal with representative statements with inequalities, and I think we've not touched the other way around. That is, we can interpret inequality to a statement form. So what we just did is just to interpret from a statement form to inequality form. So in our next class, we're going to look at interpreting from inequality form to a statement form. It's very, very simple. Then from there, we go to how to solve inequalities and so on like that. Now, look at these exercises. 5, you have to rewrite using the inequality symbols. 5 is greater than 3, minus 3 is greater than minus 5, blah, 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 and so on like that. Now, since the beginning of this class, I've been telling you that whenever you want to do my assignment, do it inside your jotter by writing. You write it out, then you snap it. Most of you people, your cameras are not too good enough. It's not too clear. Please look for a better phone to snap it and send it to the email on the first screen. And I will appreciate and I will acknowledge it. Thank you very much for your time. Then for your further readings, Stand Mathematics Book 2, page 97, New General Mathematics Focus. Then the YouTube links, they will be of good help. Please try to explore, ask questions from me, send your questions, send your suggestions, send anything that you feel like that you can just share it with me via this email address on the first page of the slide. Thank you very much. Bye.